Hello, ladies and gentlemen. Today we're going to continue on our journey with logarithms, and we're going to be looking at graphing log functions. So we're going to take a look at what these graphs look like when they contain the word log, okay? So for this, you're going to need something to write with, definitely a scientific calculator, and we're going to make 3 graphs in our notes today after we get some general ideas down, okay? So that's our plan. Here we go. So think back with me. Don't write this part down. Let's remember exponential functions. So let's remember when we would make tables like this, you see over here, with x's and y's. And remember, we chose these x values. And we would just go ahead and plug in, you know, -2, -1, 0, whatever numbers we wanted. And we would make a beautiful graph of exponential growth or decay. In this case, exponential growth. Okay, so 1, 3, 2, 9. Remember, we would make this beautiful graph go like this, and he'd be exponential growth. And remember, key parts of this graph included domain, range, and asymptotes. So remember how we would think, remember how we would find those? Domain is all reals. Okay, the range, what are the y values doing? And remember that all came from us identifying an asymptote here. And the asymptote is that leveling off spot right here, this line that the graph gets really, really close to, but never truly touches. So this blue line represents the asymptote for this graph, and this asymptote would be we're at y equals 0 because it crosses through the y-axis is 0. And then my range would kind of come from that. I would say that my range is y's are greater than 0, not greater than or equal to because they never really touch that line. They always stay above that line. So y is greater than 0. Now notice the domain is all reals, the range has some special description, and my asymptote was y equals 0. When we get into logs, ladies and gentlemen, things are going to change just a little bit. Get this one in your notes, okay? We're going to be graphing log functions today. What you see right there is an equation. We want to make a graph for f of x, which is just like a y. So y equals log 3x. That's another name for this business right here. Okay, y equals log base 3 of x. So when we want to make a graph of this, we can't approach this in the same way as we do an exponential. Exponential functions, whether they are growth or decay, we can plug in those values for that exponent and everything's fine. What we need to do to figure out how to graph this guy is to take him what's now in log form and convert him into exponent form. So remember, this is where it's handy to know how to change from logs to exponents and vice versa. So exponent form is when you have a base to a power equals some value over here. Okay, so base to some power equals some value. So what are we going to write right here to help us figure that out? Well, what's the base of our log right here? The base is a 3. So the exponent form would be 3. What power is on that 3? What exponent? Well, remember the exponent, when it's in log form, the exponent is always alone. He's isolated on the other side. So that right there, the y, is the exponent. And then what value does it equal? That's this spot right here. So I've converted an expression or an equation from log form into exponent form. This exponent form is what I'm going to use to help me create that table. So taking it from log form, converting into exponent form, and then I can create this table. Now, where will I be plugging in values into this exponent form right here? Where will I be sticking in numbers, plugging in numbers? It's not for the x anymore, you guys. It's the y, okay? Right up there at that power, that's where I'm plugging in numbers. This is where I'm going to plug our numbers in at. So when we go to fill in our table right away with appropriate values, like -2, -1, 0, 1, 2, they're not going to go in the x column anymore. They're going in the y column. This is the first type of function that we've done where we're going to plug in values for the y because his exponential form has a y up there for the exponent, okay? So what we do then is we go ahead and we plug in 3 to the -2, and that's going to tell me what the x value is. And then 3 to the -1 is going to tell me what the x value is. And then 3 to the 0 tells me the x value. And then I can go ahead and fill in this table based on those x values. So that's 0.33 repeating. Let's see, this other one here would be 0.1 repeating. Okay, and then if I plug in a 1 up there, 3 to the 1 is 3, and then 3 squared is 9. So when you go to graph this, it's going to look a little funny because these points are still x's and y's, but I put all the nice numbers I plugged in over there in the y column, and now my x values have some decimal values there. So I'm going to go over 0.11, down -2. That's like so close to the y-axis. Over 0.3, down 1. 1, 0, 3, 1, 9, 2. And the graph that we're making here, a log function, will have a nice curve in it like that. Okay, this is the general look for a log function. So right here, we're going to be constantly increasing up. But the leveling off or the asymptote, ooh, I can't write on that side of the board, that spot that we're looking for right there is now in a different location. Okay, right here, the asymptote is going straight up and down, and that blue line is following it. So now instead of my asymptote being y equals 0, it is now x equals 0. It goes up and down through the x-axis at 0. How does that change the rest of what's happening? Well, remember, the range is where I put in the numbers I wanted. I put those in the y column. So now my range is all reals. And then my domain is still a description of the x values, but now my x values as related to that asymptote. Okay, are they bigger than that asymptote? Are they on the right side? Are they on the left side? So my domain is x is greater than 0. Look at all my x values here. They're greater than that asymptote, okay? So this idea of domain, range, and asymptote kind of switching roles because logs and exponential functions are inverses. That's right. Write this one in your notes. Graphing comparison. So exponential functions, ladies and gentlemen, when you graph something in exponential function, when it doesn't start as a log function, domain is going to be the all reals, the range is going to be y is greater than or less than something, and then the asymptote is going to be y equals something. When you graph a log, things switch around a little bit. Log functions, the range is now all reals. Okay, the domain is x is greater than or less than something. And then the asymptote is now x equals something. Notice how the x's and y's have shifted roles. And that idea is an inverse one. Remember when we switch the x's and y's around? That's the idea, okay? So because exponential functions are inverses of log functions, we're going to see some of the same things, but their roles are reversed. Let's take a look at this second example here. Now remember the f of x over here, this is my log, okay, log form. But I'm not one to graph him when he's written like log form. I must convert him to exponent form. So this is like the y. So when I convert him into exponent form over here, and I'm going to use that to make the table, remember we start with the base. The base is a 3. What power is the 3 going to be raised to? The exponent is alone on the other side, so that's y. Equal sign. What's the value of that log there? Okay, log base 3 of something. That something is the x minus 4. Notice how they're trapped together in parentheses like this. That's important. Okay, so far I have 3 to the y equals x minus 4. Remember on that other one I had 3 to the y just equals x? I don't really want that minus 4 over there with that x. So I'm just going to add him to the other side, and it creates 3 to the y plus a random 4 equals x. This is the equation I'm going to use to generate my table of values that's going to help me generate this graph. Now remember where we're going to plug these values in at. We're going to plug them in the y column. That's right, because we're going to plug numbers in right there for that exponent. So we're going to plug them in the y column. Now when I do that, you can just type that in your calculator, 3 to the -2 power, and then add 4. Make sure that 4 is not up in the power or the exponent. You're going to get 4.11. This next one you're going to get 4.33. This next one you're going to get 3 to the first is 1 plus 4 is 5. And then you get 7. And then you get 9 plus 4 is 13. Okay, and we make a picture of this just like the other one. Be very careful because we're going over some maybe decimal amount and then up or down next. Okay, so over 4.11, down -2. Over 4.33, down 1. over 5, 0, 7, 1, 13 up 2, somewhere over here. Swooshing here, my log graph, making him curve. Okay, making him curve. So domain, range, and asymptote now, ladies and gentlemen. Do you see the asymptote here? The asymptote line would be right here, okay? That asymptote, that graph will not touch, okay? Will not cross. What is that equation? That is going through the x-axis at 4, so my asymptote is x equals 4. From that, go ahead and write the domain. The x values, are they greater than that 4 or less than that 4? They're greater than 4. And then the range is going to be all reals. Okay, that's where we plugged in the numbers we wanted into the y spot. There we go. Our beautiful log graph. Taking log into exponent form makes it easier for us to make great pictures. Last but not least, third one. Let's go ahead and write what this one means in exponent form. So this is like a y. So y equals 5 plus log 3 of x. And we need to convert him into exponent form. Well, I see the log base 3, and I see the exponent over here, and I see the value here. What's up with that 5? He doesn't really have a spot in log exponent form right now. Because of that, and because he can be moved, we should move him right away. In the last problem we did, the x minus 4 was together in parentheses. We couldn't move anybody. That 5 I should subtract right away. He becomes y minus 5 equals the log 3 of x. And now I can convert him to exponent form. Who's the base? The base is a 3. What's the exponent? The exponent is on the other side. So the exponent is both the y and the minus 5, ladies and gentlemen. And that equals the value x right here. So base, exponent, what it equals. All right, so now we're going to go ahead and do like we were doing before and choose some y values to plug in. Be careful on this one. You can continue with your -1, -2, 0, 1, 2, but you're going to get some pretty small values. See, when we plug in -2 up there, that's -2 subtract 5 more. That's going to give me a -7 power. That's going to get pretty small. So maybe I don't want to start with -2 on this one simply because I'm subtracting 5 from that y value and that power first. So maybe I would want to start with 3, and then 4, and then 5, and then 6, and then 7. Just to kind of give some variety in there and make sure that my answers are not going to get too small. So when I type this in my calculator, be careful. This is 3 to the power of 3 subtract 5. Both of them are up in that exponent spot, which is the same thing as a -2 power. So 3 to the -2. Okay, that's 0.1 repeating, right? And then the next one is 3 to the 4 subtract 5. That's the same thing as 3 to the -1 power. That's 0.3 repeating. And then the next one would be 3, oops, ran out of room. 3 to the 5 minus 5. That's 3 to the 0 power. That's 1. And then so on, plugging in those values and finding those numbers. And then we'll go ahead and make this graph. So we go over 0.11, up 3. Over 0.33, up 4, 1, 5, 3, 6, 9, 7. So I can still see the curve happening right here, okay? But notice the asymptote is still located right along that x equals 0. I like it, okay? So the asymptote, x equals 0. My domain, x value is greater than, less than that. Looks like they're greater than 0. And then my range for log graphs, remember that's how we started, my range is going to be the all real numbers, okay? So that's the idea for graphing logs. You must convert him from log form to exponent form and plug in to the y values, okay? We'll continue to practice with this. Thank you for taking good notes.